Hey, what's up YouTube? So here in this video I'm going to be showing you my new workbench light that I've constructed out of spare parts and electronic surplus. And we're going to be taking a look at the circuit configuration here on top of the battery, as well as the LED here, which I got out of a broken microwave. And I'm using that as the output LED source for lighting. And we'll be taking some measurements using this multimeter here. Alright, so for the power source I'm using this portable DC-DC lead acid sealed rechargeable battery, which is rated for 12 volts at 12 amps per hour. Okay, so as for the circuit here, it's all closed loop and linear. So I have the positive tab of the battery here connected to the base of this transistor here. Now I'm actually using a unique transistor in that this is a high voltage power transistor, NPN type. Now although these aren't typically used in a linear fashion, I can get away with it due to the efficiency of this transistor here, and is well suited for general purpose applications. As for the load, I'm using a 5-watt power resistor of the ceramic type rated for 33 ohms of resistance, and I have that connected from the base pin to the emitter pin, and then the positive output pin, which is the collector pin, is connected to this Schottky diode, which is in the forward bias position, and I have that going out to the positive output of the LED here. So additionally, I have another power resistor over here, which is connected from the heatsink, which is case negative, and that's going to the negative input of this power resistor here, which is rated for 2 watts of power. And I have the positive output going to this positive lead of the ceramic capacitor here, and I have the output of that going directly to the positive output of the circuit here. And I'm using this capacitor mostly for coupling, and that's giving me a bit more power draw from the circuit. I have the negative tab of the battery connected to this 100 ohm resistor directly, and that goes out to the negative output of the LED here. Okay, so as for the LED here, this is a LED that I removed from a microwave, and it outputs purely white light, quite bright and luminous white light. And I have that heat sinked here to this aluminum sink using lithium grease on the base of this aluminum heatsink of the LED here. And then I have it thermally bonded externally around that. And then I have the heatsink thermally bonded here to this heatsink right here, with a fan installed on the back for additional cooling if I need it. It's not necessary considering the efficiency of the circuit here, but there's the 12 volt adapter that I can plug in for turning on the fan. As for the LED configuration, it's really quite simple. We have the negative coming in here, and here's the positive lead for the positive alligator clip coming from the circuit of the battery. And here we have 2 surface mount resistors, and those basically feed the diode by dumping the voltage and current coming in from the voltage and current source into the LED here. And here we have the workbench light in operation here. And with the lights off. So as you can already probably tell, this is a very useful workbench light. Not only that it is portable and rechargeable, it also is very bright and has a relatively high lumen output. And like I said, it is also quite efficient in terms of its operation. I could leave this running for hours, and this LED and these resistors here, and this entire circuit entirely, won't even get warm over that period of time. Amazing. Okay, so now for measurements, and we're using 11.6 volts in circuit there, and that's converting down to the LED here. So here I'm measuring the input of the surface mount resistor, and we have a positive 9 volts there, well, a potential of 9 volts there. The output of that surface mount resistor going directly to the LED is 8.3 volts there. So that's actually what the LED is using to turn on and turn off here. And also considering the fact that the LEDs that you can find in microwaves tend to require a bit of a higher voltage than your typical white LEDs. So this 8.3 volt measurement actually checks out for these type of LEDs here.